Now we'll derive an expression for electric field due to infinite sheet of charge with the help of Gauss theorem. Now infinite sheet of charge means if we have a sheet which is infinite in size and it's a thin sheet, that means its boundaries are not defined. So we show it like this, that we have taken a part of this sheet and say this sheet is positively charged. From this sheet at distance r, there is a point P at which electric field is to be measured. Now, for this purpose, we have to choose a Gaussian surface so that we can apply Gauss theorem. So we take a cylindrical surface. Gaussian surface here is cylinder of length 2r and radius any. That is of our choice, we can take any radius. So r length is in front of the sheet and r length is back side of the sheet. So that means the cylinder will pass through this sheet, it will go across the sheet here and will go on the other side of the sheet. So this is the cylindrical Gaussian surface. Here we take this cross section, say, as surface 1, the curved surface of cylinder as surface 2, and this cross section as surface 3. As positively charged sheet is expanding in the vertical direction, that means it will go in this direction and downward in this direction. So at this cross section, the direction of electric field be away from positive sheet, so we can take it this side, and the area vector of this cross section will also act in the same direction. Now same way, for this cross section, electric field is outside and area vector of this cross section is also in the same direction. For curved surface, electric field is here because it will be away from positive charge, and for curved sheet, area vector is in perpendicular direction. Now we apply Gauss theorem. According to Gauss theorem, we can say flux is equal to E dot dA surface integral. So this will be the part 1 plus part 2 plus integration for the third surface 3 equals to Q upon epsilon naught. Now we can see that for for second surface, the area vector and electric field, they both are perpendicular. So this integral will be 0 because here theta is 90. And 1 and 3, they both have same value, E and A, both in same direction. Theta will be 0. So this is simply E into A. So we can write it as twice integration of E into dA, that is equal to Q upon epsilon naught. 2 E is out of this integration sign, so integration of dA Q upon epsilon naught. Here, because this is infinite sheet, we don't know how much charge will be there on the sheet, so we define surface charge density, which is sigma, and this is Q upon A, charge per unit area. So from here, we can write Q as sigma into A. So it will be 2E. Total area of the sheet will be A. sigma into A, area will be cancelled. So we get E is equal to, here epsilon naught will also be there. So we get sigma upon 2 epsilon naught. This is the electric field of an infinite sheet, charged sheet, sigma upon 2 epsilon naught. Now here we see that in this formula, the distance, that is the position at which electric field is to be calculated, is not there. Means electric field due to this infinite sheet does not depend upon the distance, whether this position is near to the surface or it is away from the surface. At all the positions, electric field will be same. It will be constant.